Welcome to the Data Legos API Developer Guide. Today, we'll be discussing two critical aspects of modern APIs: how they integrate with external services and how we secure them against attacks. We'll cover how to call third-party APIs from within your own API, and the essential practices for securing your API from external threats. When your API communicates with another external API to fetch, send, or process data, this is called third-party API integration. This allows your system to expand its functionality without having to build everything from scratch. Here is the step-by-step flow of how this works. First, your API receives a request from a client. Your API then makes an HTTP request to the third-party API. The third-party API responds with data, usually in JSON or XML format. Finally, your API processes or transforms this data and returns it to the client. A great example of this is building a travel booking API. When a user searches for flights, your API doesn't have that flight data. So, your API internally calls a third-party service like the Amadeus or Skyscanner API to get real-time flight schedules. Your API then takes that information and sends a neatly formatted response back to the client. A common question is, why not just call the third-party API directly from the front end? The reason is security. Calling it from the front end would expose secret keys and credentials, which is a major security risk. Your API acts as a secure gatekeeper. Securing an API means applying techniques to protect it from unauthorized access, misuse, and attacks like data leaks or denial of service. Here are some key security practices. Authentication and authorization: you must verify who is calling the API using methods like API keys or OAuth2. Rate limiting and throttling: restrict how many requests a client can make in a specific timeframe. Input validation: always sanitize and validate client inputs to prevent injection attacks. HTTPS/TLS: encrypt all communication to prevent eavesdropping. API gateway/firewall: use these to monitor and block suspicious traffic. This is your first and most fundamental layer of API security. We can think of it like a bouncer at a private club. Authentication is when the bouncer checks your ID and confirms you are who you say you are. For an API, this means the server checks for a valid secret key or password in a user's request. Authorization is when the bouncer looks at your special wristband to see if you're allowed in the VIP lounge. An API does the same thing. After verifying your identity, it checks your permissions to see if you're allowed to access a specific piece of data or perform a certain action. Next, we have rate limiting and throttling, which are a defense against a type of cyber attack called a denial of service (DoS) attack. A hacker could try to flood your API with millions of requests at once, hoping to overwhelm your server and make your service crash or become unavailable for all of your regular users. Rate limiting stops this by setting a strict limit on how many requests a single user can make in a short period, preventing anyone from crashing the service. On a similar note, throttling controls the rate at which a user or system can access a resource by slowing down requests instead of blocking them completely. Input validation protects your system from malicious code. Think of every input field, like a username box or a search bar, as a potential entry point for a hacker. Without validation, a hacker could type in a command instead of a username, a command designed to delete your entire database or steal user information. Input validation is the process of checking every piece of incoming data to make sure it is safe and in the expected format before it is used by your application. This is about ensuring data privacy. Without encryption, any data you send, like your password or credit card number, is like a plain message that a hacker could read if they managed to intercept your connection. This is called a man-in-the-middle attack. HTTPS/TLS scrambles your data as it travels, making it unreadable to anyone who isn't the intended recipient. It's like sending your data in a secure, locked box that only the server has the key to open. API Gateway centralizes security. It's much easier to protect one single point of entry than to protect dozens of separate services. The gateway acts as a security hub where you can apply all your rules, like authentication and rate limiting, in one place. A firewall then acts as the outermost wall, automatically blocking common, known threats before they can even get to your gateway. Together, they create a strong, layered defense for your entire system. Imagine running a payment processing API. Without security, a hacker could attempt thousands of fake transactions per second, overloading your system. By using rate limiting and authentication with OAuth 2, you ensure that only registered clients can call your API and only within the allowed limits. This prevents fraud and keeps your system stable. To wrap up, calling third-party APIs allows your system to extend its functionality by using external services. At the same time, securing your API is not optional, it is essential to protect your system, users, and data from attacks. Together, these two practices ensure that your APIs are both powerful and safe. Thank you.